Hello and welcome to pdfsupply.com. Today we're going to be testing an RX3i analog input card. I have here an IC695ALG626. This is a non-isolated analog input. It's capable of 8 or 16 channels depending on your settings. It's something that we'll get into shortly. And it measures voltage DC negative to positive 10 volts. And current DC in milliamps, 0 to 20 milliamps or 4 to 20 milliamps, depending on your needs. The basic test is that we're going to go over some troubleshooting, explain what some of the lights mean, how you can detect if there's a problem with the card, how to test each channel, and how to configure it properly. There's a lot of configuration that's involved. So before we get started, what you have in front of you right here is a terminal block that's a high density. There's 36 terminal screws. Now if you'll notice, my terminals 19 through 36 are all jumpered, all right, with the exception of number 28 doesn't actually have a jumper on it. But this is for when we test current. So if you're attempting to make this test and you need to test current as part of the test to make sure the card's in good working order, you'll need to make all these jumpers the way that I have here, okay? The small wires are fine because the amount of energy that's flowing through is very low. All right, so you don't have to use too much. That's the terminal block. Now it gets placed on the module, and then the lever here should be in the most upright position. And when it is fully connected and making connection with the card below it, you're going to get a green LED where field status is and green that the terminal block is in place. Okay. Now, the light pattern that I have here is the same light pattern that you should have if you have from the start a good working card. If you don't have a module OK light or your other lights aren't working when this is fully connected, then there's some sort of a problem with the card from the start, and you won't be able to follow this test. And the card will need replacement or repair. Okay? So then, once we've got it physically connected in the rack and turned on, your lights are in the right position, then we're going to connect up to the processor. I'm using Proficy Machine Edition software. The first thing that we want to do before we connect actually is go to your navigator bar, and we want to install the same physical configuration that you have in front of you. So I'm using a 7-slot rack, CHS007. You can follow this test with a 012 rack or a 016. It doesn't matter. My power supply and your power supply will be using 2 slots, 0 and 1. And the processor, my CPU 320, is using slots 2 and 3. Leaves me with the next available slot for this particular test as slot number 4. Okay, so I'm going to go ahead and click right click or double click on slot 4 and select add module. As we said, it's an analog input, and it's an IC695ALG626. Okay, now before we get connected, we want to do a couple things here. For this particular test, I'm showing you how to do all 16 channels. Okay. Now, before we actually get into each particular channel to adjust their settings, you want to note your reference address. So when we open up our reference tables, our analog input table, you know where to look. %AI, which is analog input 00001. So when we probe each channel, that's the place that we're going to start. All right. Second thing is if you choose to, and I'm going to go over this again later, test only 8 channels. What you would do is go to the analog input mode and hit differential input. Okay. Now, if you look on my software, I've dropped from 16 channels in total to 8. All right. But I want to test the entire card, every channel. I can expand it out to 16 channels the way it is in the default setting. Next thing is each channel is disabled to begin with. All right, that's the default, is disabled. So the first thing we want to do is enable it for voltage or current, and the first range that comes up when you adjust it to a working circuit is negative 10 to positive 10 volts DC. That's fine. We'll stick with that. And then to adjust our scaling, we're going to go to the channel value format. We're going to switch our format to 16-bit integer. And you're going to get 10,000 as your highest value and negative 10,000, which means that if you give it a positive 10 volts DC, you're going to achieve a figure of 10,000 in your integer in the table. All right. And we go ahead and do this with all the channels. 16-bit. Turn the channel on, voltage current, 16-bit. I'm just going to do this with half a dozen channels just as an example of how this works. But in the event that you're testing the full card, you would go through all these channels, all 16, and switch them to voltage current. It's going to default to negative 10 to positive 10 volt DC and 16-bit integer. Okay. Next thing I want to do is connect up to the processor by hitting the online offline lightning bolt icon here. And once we are fully connected, we're going to hit the green handprint to toggle us online mode. All right. Now follow me down here, follow my arrow. This status bar at the bottom is important. It's telling us that we're in programmer mode currently because we're toggle online. The outputs are stopped and disabled. The configuration and the logic are both not equal. That's because the processor is telling the software that it doesn't recognize this ALG626. It was doing something different before we've asked it to test this. So for that reason, we're technically faulted. Go to Target, Online Commands, Clear, and we want to clear controller and I/O fault tables. Okay, we'll clear those faults. Ask it to forget about that. I'm going to hit OK. Yes, we're going to clear those, and then we're going to hit Download and Run. Download and Start Active Target icon here. Now you must clear those tables before we get this far, because otherwise you're going to get hung up in the download process. It'll recognize this card, new card, as a mistake. So when it asks us what we want to download to the controller, it's just hardware configuration and motion and logic. We'll say yes. There's no need to write anything to permanent flash memory or start any initial force values for this simple test. We're just going to probe the inputs to get a response. All right. The download process takes about a minute or so. Once it's complete, the next thing that we're going to want to do is open up our reference tables I mentioned before with the particular reference addresses. I'll show you what that looks like and what it should look like when it's being probed. For the voltage DC side, all of the channels are located on the left hand side. Okay, there's a common input. The common input is number 5, terminal screw number 5, and terminal screws number 14. Just those two screws. All of the other screws are positive inputs. Okay, so we're going to start the controller, and once you enable the outputs, your processor should be in run mode. If it's not, check to see if you have any errors in your download, and or simply open your processor door and make sure that the switch is in the far right hand position, which enables the outputs. Okay, but once you're in run mode, you can follow me here. What we're going to do is go to default tables, expand on that, double click or right click and open your analog input table, and you'll notice that in the upper right hand corner is the analog input 001. That's our first input. So what I'm going to do is you can use a 0 to 10 volt DC generator if you choose, and check the range and resolution. What I do for voltage DC is I use a 3 volt memory battery with 2 leads coming off, a positive and a negative. So I'm giving it about a third of its range, of its power, something kind of in the middle. And what I'm going to do is I'm going to place my negative probe on the terminal number 5, which is my common, and I'm going to probe starting with screw number 1, which is channel number 1 voltage, and I'm going to make my way down. Okay, you'll notice that every other address location will illuminate with the value that it's giving you. Take note that my values are stable. Okay, so the integer value that I'm getting is 2144, 2145 roughly, but it's not moving up and down erratically. Okay, it's pretty stable, and the value is correct based on the amount of voltage versus the scaling I'm using. Okay, what I would say here is that if you have no response to the channel, that means that circuit is bad. If you have a response that's extremely erratic, where it's jumping from 1900 to 2200 and maybe all over the place, and it won't stay still the way mine is, you've got a circuit that's bad. Okay, and any of those two things. The other thing is, and I see this very commonly, especially with analog input cards, is you may probe it with this 3 volts, and it'll be telling you that you're giving it 10 volts. What that means is the circuit will fail at full value. No matter how much power you put on it, as soon as you probe it with something, it's going to tell you that you have 10 volts there. It could be 1 volt, it'll tell you have 10 volts. It could be 3 volts, it could tell you have 10 volts. That's another problem. And that's definitely a failed card. So any of the 3. Circuit must be stable, circuit must give you a reading, and the circuit must give you an accurate reading for the amount of voltage that you're giving it. It should not give you a maximum voltage unless you're actually giving it 10 volts. Keep that in mind. Okay, so the next thing is you would just carry through with your negative lead on 5 or 14, depending on which channels you're probing, and continue to probe the other channels, the other terminal screws, with your positive lead to go through and check all your inputs. All right, that's the voltage test. And what we're going to do is we're going to stop the controller, disable the outputs, and we're going to go back through our channels, starting with channel 1. And we're going to leave everything the same, except we're going to go to our range, which is the middle selection here, and select. I'm using 4 to 20 milliamp generator, but you can use 0 to 20 milliamps if you are using something that low. Feel free to do that. Okay, the 0 to 20 milliamp is this selection right here. Again, I'll just do the first 6 channels. Now, our wiring is going to get in our probing is going to get a little different. Rather than using the terminal strip in a vertical pattern the way that I just did with the voltage, we're going to be using it in a horizontal pattern. All right. If you look at your wiring diagram, channel 1 input for current is positive lead on number 1 and negative lead on number 19. Okay, so they're opposite each other. You're using both left and right hand side of the terminal strip. Other thing is you must make sure that you have your terminal strip jumpered the exact same way that I do, which is indicated on the wiring diagram if you see there, but you can actually physically see it on my terminal strip how it should look. And that's how we're going to get a response. So we're going to download and run this. First thing we're going to do is check our status again. Configuration is not equal because the processor was doing voltage before, not current. And you have an asterisk here, a little star to the right telling you, hey, something is different here. Go to Target, Online Commands, Clear, and we're going to clear controller and I/O fault tables again, just like we did before. And then we'll download and run that configuration. Okay, this new milliamp current configuration. Again, it takes about a minute to download. But once we do, we'll be able to start probing these inputs, and I'll show you guys what to look for and how I test these. I do a slightly different test on the milliamp side because I'm actually using a generator where I can dial up and down the different values, and I highly recommend that you do that. I'll show you why in a minute. And we're just about getting done here. Okay. Now, once we're able to get into run mode, same thing. Or turn on our outputs enabled. Make sure that your processor is in run mode. Make sure that your status is programmer. Run enabled, configuration and logic are equaled. Enabled means that the I/O inputs and outputs are enabled. All right, so once you have all that, we're sure our settings are correct. We're going to go to Analog Input Table, and you're going to see values that appear there, and they'll appear in the channels that I've selected. So again, I've only decided to go through 6 channels just as an example for you guys. I recommend that you do all 16. Oh, and just to go back one more time to show you guys, if for some reason you're only using 8 channels and that's all you want to test, or if you want to test 8 channels in addition to the 16 channels, simply go to Differential Input and change it right there. Okay. All right, so now it's time to probe these channels, and as I was saying before, we're going to use a different sort of probing pattern. Instead of a vertical pattern, we're going to do horizontal. My negative lead should be attached to number 19 and my positive lead to number 1. Okay, now I'm attached and I already have a value of very nearly 20,000. Okay, very close to 20,000. It's extremely stable. So same thing as before with the voltage. It must be stable. It must give you a reading when you probe it. If you're wired correctly, you'll get a reading. If there's something wrong with the analog card, you will not get a reading. That's a damaged or a circuit that needs replacement or repair. Now I'm going to dial down my values. The reason I'm doing this is because of the same thing that I explained before. Typically, with this particular card, or any analog card for that matter, they fail at full value. So you may probe it, it may seem like it's working okay, but if it gives you an immediate value of 20,000, if you're giving it 20 milliamps, that's fine. But if you dial it down the way I just did, and this value is not changing, then you have a blown circuit. Okay, it's an easy way to tell. We'll do number 2. Then I'm going to start from 12,000, work my way back up to nearly 20,000. Okay, go to 3 and 21, which is my input number 3. Dial it down. Okay, you can see it going down. Input number 4. Okay. Input number 5. Having a devil of a time getting connected, but you guys get the point pretty much. I'll stop the test right there for that. So just to recap from the start, when you put the module in, you should have a blinking module OK light. When the terminal is connected and it's wired properly, you should have a field status green LED, a terminal block green LED that tells you that you're perfectly connected. Once the processor is in run mode and you're configured equally and logic is equal, you're in run mode, you should be able to test these circuits with either DC or a voltage DC or milliamps, depending on what your needs are and what you're looking to test. The circuits should be stable. The circuits should give you a reading, and the circuits should give you a stable, accurate reading. it's a very sophisticated analog input card. So it should give you an exact reading. It shouldn't be fluttering around or anything like that, the values. If you have any of those problems, if any of those things fail or go wrong or don't go the way that this test was explained to you, then that's definitely a card that you know by testing now is broken. It needs repair or replacement. The IC695ALG626 is a card that we do repair here at PDF Supply. We offer exchange programs, new and remanufactured products, and same-day shipping. So if that's something that you need or interests you, please see us at pdfsupply.com. Thank you.